Hello, for this worked example, we've got a main arm of a crane. So this is a crane setup shown below here. This main horizontal beam has a mass of 400 kilograms. And we're going to assume the center of mass is the center point of the beam. It's supporting a 200 kilogram load, as well as a 600 kilogram counterweight over there. We're going to assume this right here is a pin joint, so it allows for rotation, but not motion in the X or Y. And we've got some support cables as shown here. So we're asked to draw a free body diagram of the main horizontal beam, including all the forces that are at play here. So first thing I'm going to do is I need to separate that horizontal beam from everything in the surroundings. So just the horizontal beam. And draw that just like so. And then we need to start taking into account the various forces that are going to be at play here. So with this, if we kind of go from the left to the right, so I've got a cable here. I'm going to have a tension in that cable. So I'm going to start by drawing in. I'm going to call this one tension 1. I'm going to have the counterweight. So the counterweight, the center of the counterweight is kind of 3 meters in. I'm going to draw that next. I'm going to just call this one FCW. And that's going to be 600 times 9.81 if I want to do that. So I can add that as well. Next up, I have my pin joint. So the pin joint is not going to provide a moment, but it is preventing motion in the X and motion in the Y. So I'm going to have two unknown forces there. I'm just going to call this FRX and FRY. Then I'm going to have the tension from this over here. I'm going to call this one tension 2. And then I've got the load force itself. So the tension from the load force, I'm going to just call this one TL. And that one, again, I'm going to know kind of it's going to be equal to 200 kilograms times 9.81. That will be the tension I would expect in that cable there. The load I don't have kind of from any of the background is the weight of the arm itself. And so I got to figure out how far in that is. And so if I do 3 plus 10 plus 20 plus 10 plus another 7, so this part is 40, and then add another 10, that's going to be 50. So 25 meters in is going to be the center. And so if I look at that, the center is going to be somewhere around here. Between that 25 meter mark is going to be between my anchor point and the tension force over here. So FG, and that's going to be equal to 400 times 9.81. All right, so lots of things going on. So all of my forces are identified at this point. I've got the counterweight, the gravity force of the crane itself, and then the load force, the two tension forces from this cable, as well as all of the reaction forces at the pin joint. So next up, I'm going to want to identify any key angles as well as any key distances. So let's start with the angles. So I'm going to need to do a little bit of math because they're not given here, but I'm going to need to know this angle and this angle. And so I'm going to call this one theta 1, this one theta 2. Let's do a little bit of math and we should be able to figure that out. So for theta 1, that's going to be, if I look at this triangle here, it's 13 meters this way, 6 meters up. And so 6 over 13 would be the tangent. So if I do the inverse tangent of 6 over 13, I get theta 1 is going to end up being 24.8 degrees. And I can do the same thing over here, except it's 20 meters. So theta 2 is going to be the inverse tangent of it's 6 meters vertically, so opposite over adjacent of 20 meters. So 6 over 20 this angle down here is going to be equal to 16.7 degrees. And so those can go in here. I'm going to put in 24.8 degrees as well as the horizontal there, 16.7 degrees. All right, so that's my key angles in this. Next up, I need to kind of translate a bunch of these distances into my diagram. Counterweight to the end tension, that's going to be 3 meters. It's just kind of this distance right here. It's another 10 meters from the middle of the counterweight to the pin joint. And then next up, so it would be 20 meters between this and the next tension force. But it's also going to be, remember the whole thing was 25 meters long, or sorry, the whole thing was 50 meters long, so 25 meters in is where this would occur, where this piece would happen. And so 25, I've got 13. If I go another 12, let's go 12 meters. That gets me to my center point. It's going to be somewhere around here is where the center of gravity is. And then another, so if I've got 12 of the 20, I go another 8 meters. I get to the tension force, and I go another 7 meters. And I get to my load force. Or sorry, that's the wrong number. The 7 meters actually is going to be irrelevant. It is 10 meters from the tension force to the load force over there. So this should be 10 meters. All right, and with that, there's a lot going on in this free body diagram. Certainly not the simplest free body diagram in the world, but I do have the separated arm. I've got all of my unknown forces, known and unknown, on the diagram, as well as all of the key angles and all of the key distances labeled. From here, I could build my equilibrium equations, start solving for some of those unknowns. So that's all we got for this example. Thank you for watching, and I hope to see you again.